All right, good afternoon, everyone. Thanks for joining us for today's webinar on fast roaming and multi-WAP environments with Araknis Networks. I'm Heidi Nilsson. I'm a marketing manager at SnapAV, and I'll be moderating today's session. Before we get started, let's go through a few quick housekeeping items. First, we will be sending you a recording of today's presentation. Within the next couple of days, you should receive an email with a link to the video, as well as a coupon code for $50 off your next Araknis Access Point purchase. Second, we do have a Q&A session planned for today, so please send in your questions at any time using the question and answer feature in the GoToWebinar control panel, and we'll get to them at the end of the presentation. All right, now I would like to introduce you to today's presenter, Aham Eriksisi. Aham is the category manager for Araknis Networks here at SnapAV, and he manages the research and development process for all of our networking products. He's been with SnapAV for over 3 years and in the networking industry for 10 years, working at large companies like Nortel and Huawei. Welcome, Aham.
Thanks, Heidi. Welcome, everyone. Thanks a lot for your time in this afternoon. I see that we have a lot of excitement and a lot of people RSVP'd and on the call today. So this will be a very hot topic for us. I think there's just 1 second, Heidi, I can't flip the slides. Oh, here you go. I'm sorry. I'm good. All right, so this session we'll talk about Wi-Fi and everything Wi-Fi. So there will be a lot of conversation around our recent updates, especially the most recent firmware update. But this session will be split into 2 parts. The first part will be talking about technology, where we are in technology, specifically wireless AC and controllers. And the other half will be talking about more of a practical guide on how a typical install in a multi-access point environment should go. Like Heidi mentioned, there will be a Q&A session towards the end, and this time we listened to you from the last session that we need more Q&A, so I think we allocated around 30 minutes of Q&A. So please submit your questions through GoToWebinar. Heidi will go through those questions towards the end. But let's get started. So the first part is the technology. So wireless AC, why should you care? What's new and where we are? So this is a slide that probably shown you guys last time for those of you who were on the call. And this is an evolution of Wi-Fi standard. So Wi-Fi as a standard started way back in '97. It's been a long way since we started with doing, roaming and wireless Ethernet, basically. And it started with the IEEE. They formed a subgroup called 802.11, and they specify in everything Wi-Fi. So you can see from the evolution, 802.11 first version had no numbers appended to it. And it started as 2 megabit per second maximum throughput on 2.4 gigahertz. And why 2.4 gigahertz? At that time, it was the only license-free spectrum. So no one should buy any special licenses to and pay FCC any royalties in order to operate on that frequency. So a lot of companies, networking companies and non-networking companies actually, they start utilizing 2.4 gigahertz from the get-go. Then, the second evolution of the standard when we have, B and A. So A introduced the 5 gigahertz networking spectrum, and B increased the, the speed on 2.4. So this is more higher speed, better modulation schemes, and more technology as we rolled into the G standard, the 54 megabit per second connection or speed you can realize on both 2.4 and 5. Then it took, the IEEE a long time to roll out the major release, which was N. So 802.11n was a big deal in late 2000s, and it's it bumped up the speed quite a bit on 2.4 and on 5 gigahertz, and we saw multiple iterations of the standard going out from the chipset vendors. But at that time, if you think about the counterpart of Wi-Fi, which is the back end, gigabit Ethernet has been very prominent throughout the early 2000s, especially in small businesses and enterprises. Everything on the back end was 1 gigabit per second. All the applications were built around 1 gigabit per second connection, and life was good. But then, towards the beginning, mid to early, late 2000s, beginning of this new century or decade, the back end is starting to get higher speeds. The back end is getting towards 10 gigabit per second in enterprise. And also, applications are demanding more and more from the Wi-Fi. So that's why, the IEEE started working on their second iteration, which is 802.11ac. And 802.11ac came into, as we will see now in a minute, in a couple of waves. But the beginning of it promised more than gigabit per second connection over Wi-Fi. And that's a big deal. That's a big deal for application developers. That's a big deal for consumers because now everything is getting more miniaturized and more wireless. But I want to show you what's going in the hopper because we're a member of Wi-Fi Alliance and we get access to their development roadmap. And now they're working on 802.11ad. And 802.11ad will introduce 60 gigahertz spectrum. That's a different radio spectrum. By definition, because it's a higher number, the range will be a lot lower, but you can achieve more than 5 gigabit per second connection over Wi-Fi. That's also a huge deal. Also, it's not mentioned in the chart here, there's another technology being developed. It's called 802.11ax, and that's a completely different modulation scheme that will work on 2.4, 5, and 60 gigahertz. Will achieve much faster speeds, and we expect that to be in 2019 or 2020 deployed. So it's a quick overlook on where we are, where we've been, and where we're going in terms of Wi-Fi. But the big deal now is AC. So what is new in AC and why should you care? This chart will explain on a high level or maybe on a technical level what is new with AC. So starting from the top, 802.11n, when it was introduced, it was an evolution on both 2.4 and 5 gigahertz radios. 802.11ac, it's a 5 gigahertz only evolution. You will not see any change between N and AC in terms of 2.4 gigahertz radio in real life. Some of the vendors will say, okay, we have higher modulation speed on 2.4, but in real life, 2.4 gigahertz evolution or any innovation pretty much stalled. It's a very crowded space. But it's backward compatible. So you can see channel bonding. So what's new is the channel bonding scheme. So with wireless N, the channels, which are the lanes in the highway, the width of the lane of the highway that the traffic can go through, went from 20 megahertz in G to 20 megahertz or 40 megahertz in N. So with N, you can basically double your lane in the highway, and now you can move a larger car or a larger traffic through the highway. And that's how you can achieve faster rate. With AC, they went double that. So they can do 20, 40 megahertz and 80 megahertz. And now we'll see in the next slides that the Wave 2 AC introduced 160 megahertz. But we have to be very careful about the channel bonding. If the more channels you occupy in one traffic, the more susceptible you are to interference and other noise to be affecting your traffic. And whenever there's a noise affecting your traffic, then you have to retransmit that frame because there's an error in that frame. So going on channel bonding or higher channel bonding, specifically on 160 megahertz, can be somewhat frowned upon, especially on the 5 gigahertz, because now you're starting to occupy a lot of the spectrum. Unless you're in a clean environment, then go for it. The other thing is on N, the number of multiple inputs, multiple output spatial streams between an access point and a client per standards is maximized at 4. So that means that at one point of time between the access point and the client, there are 4 different streams going on, and there's traffic going on 4 different streams. And that number doubled on AC. So with AC per standard, maximum is 8. So you can get up to 8 streams between an access point and a client. What we've seen in the real life, because 4 streams mean that you have to have 4 antennas per radio, and also the client should support 4 antennas per radio. What we've seen is that a lot of the clients are either 1 stream, 2 streams, or 3 streams. And that's the maximum we can get today with technology in terms of number of streams. But with N, so that's one of the other innovations in N or evolutions is maximum throughput per stream is 150 megabit per second. And that was an evolution over the previous G standard, which was 54 megabit per second. So 150 megabit per second was achieved basically by changing modulation to be a QAM64. This is way too detailed, but it's something that you need to know that, it changed the number of times that, the access point and the client sample the traffic and send it very quickly. And 150 megabit per second can be achieved by using 40 megahertz channel bonding. So you can not only you have a wider lane now, but you can have more traffic going faster through those two lanes between the access point and the client. Now with AC, and that's a major step forward, is that they went from QAM64 modulation to QAM256 modulation using 160 megahertz. So theoretically speaking, with AC, you can achieve a maximum of 866 megabit per second per stream. So if you have a 3-stream situation between a client and access point, so you multiply that number by 3, and that's your maximum throughput between the client and access point. If you have a 4th-stream situation, you multiply by 4, so you can get up to 2.6 gigabits per second. But again, the client should support 4 streams, and the access point should support 4 streams. And so far, we haven't seen any clients that go beyond 2 or 3 streams in antenna configurations. The other important thing with AC is multi-user MIMO. So everything before wireless AC was what we call the single-user MIMO, or SU MIMO. Even though that the antenna's configuration supports multiple inputs and multiple outputs, at any point of time, only one device is talking. That's the nature of Wi-Fi before AC. Either the access point is talking to one client, or one client is talking to the access point. There are no situations where multiple clients are talking to one access point. With AC, with support of multi-user MIMO, now you can do up to 4 clients at the same time talking to the access point. And that increases your effective capacity of the system as a whole 4-fold. And that's only available in Wave 2, so we'll talk about that in a second. The good thing about standardization and the IEEE is that everything that, as they develop and evolve, is backward compatible with the previous version. So even though you have an AC compatible access point, it can roll back all the way to B or A. So that's a great thing about standardization in networking. The other cool thing about AC is the concept of beamforming. So basically, you've got 2 types of beamforming. One of them is antenna-based beamforming, and that's a proprietary technology by Araknis. Basically, they have multiple mini antennas on the access point, and they control the propagation pattern of the Wi-Fi based on the antennas. That's not the standard. The standard with AC is chipset-based beamforming. Basically, the access point detects where's most capacity and most activity coming from, and trying to change the propagation pattern of the Wi-Fi so it serves those clients the best and reduces side noise from the background the most. Then the standard, the chipset-based, is not as effective as the proprietary Ruckus one, but it's a different evolution of the standard. So on the bottom, you can see the difference when we talk about channel bonding. So 20 megahertz was the norm pre-N, and 40 megahertz was, combining 2 adjacent channels into one. With AC, now we're combining 2 40 megahertz into one, or we can do with Wave 2 a big 160 megahertz channel. Now, like I said, with AC, it didn't come at one stage. It came at 2 waves, basically. And Wave 1 AC, which is the majority of the devices or the access points in the market today, they came at the point where the standard was not fully finalized. They were still working on the multi-user MIMO aspect of it, and they were still discussing the 160 megahertz channel bonding option. But at that point, QAM 256 was done, 80 megahertz channel was done. So, chipset vendors and networking OEMs said, "Oh yeah, we got enough now to work with," and deliver on the requirements of higher streaming and higher applications over Wi-Fi. So let's go ahead and deploy Wave 1 AC, and then we can come back and do a Wave 2 AC. But starting from, I think towards the second half of 2015, we start to see, more Wave 2 AC access points in the market at a very expensive, very steep price points, obviously. On the bottom left here, this is an interesting chart from Cisco. This is lab results. So it shows on the left, so on the y-axis is the maximum PHY data rate, and on the x is range in feet. So you can see the difference between 3x3 N and Wave 1 AC, different antenna configuration and different channel bondings, and Wave 2 AC is very significant. But that's only on, up to 40 or 50 feet, and that's in the lab. But you can see once you get to a farther distance, 90 feet, 100 feet, the difference between those technologies diminishes. You still get a bump up between different technologies, but it diminishes. So in real life, those curves, they drop sooner because there's noise, there are a number of clients, so the more clients you connect, the more noise you introduce, the more contention you get in the medium. In real life, the difference between a 3x3N Wave 1 and Wave 2 AC is really within the first 20 to 30 feet of the access point. After that, there's marginal gain, and really, what it means for you or for your clients, even though they got a full bar or 3-bar Wi-Fi connection on their phone, it doesn't mean that they're getting the advertised speed of 800 megabits per second, for example. That speed will change with distance. That speed will change with environment, and that's why you should have, or you plan your access point to be, to cover effectively, on a multiple access point environment, and make sure that you address that problem, and you actually communicate to your users as well. But with that all being said, on the right hand bottom right chart, you can see that this is a research from ABI Research talking about how many units sold globally in terms of millions that are N only or N single band, N dual band, AC only, or AC and backward compatible. And you can see clearly the purple line is soaring. Clearly, AC is taken over in 2015 over N. So definitely you need to be on the AC bandwagon if you are, planning for new jobs. And also, end devices. So we're starting to see, more and more end devices adopting AC, in correspondence to the charts that we showed in the previous slide. So this is an example of most recent releases from both Samsung and Apple. So you can see on iPhone, iPhone 6, 6 Plus, and SE, it's AC, but the antenna on those devices are 1 by 1. So there's only one stream between the iPhone and the access point. So per standard, the maximum theoretical rate on 80 megahertz channel bonding is 433 megabits per second. With 6S and 6S Plus, now we got a 2x2 antenna configuration, can support 80 megahertz channel bonding, so we can get a maximum of 866 megabits per second. Same thing with the latest iPad. So iPad Pro 9.7 and 12, iPad Air 2, they have 2x2 antennas, 80 megahertz channel bonding, maximum 866 megabits per second. With Samsung, usually Samsung is on the hardware side a bit ahead of Apple. So from Galaxy S5, X6, and S7, they all have wireless AC chipsets, Wave 1, with 2x2 antennas, 80 megahertz channel bonding, and 866 megabits per second. 1 second, I apologize, I have to go back to this. So explaining between Wave 1 and Wave 2. So what's the difference between Wave 1 and Wave 2 is that the maximum, because with Wave 2 they introduced the 160 megahertz channel bonding option using the same QAM or modulation speed with QAM 256. Now you have double the rate or double the lanes. You can go maximum per stream from 433 megabits per second to 866 megabits per second. And the maximum spatial stream on wave 1 AC is 3, so your access point can be only 3 by 3, and your client can support 3 by 3. But with wave 2, it can be 4 up to 8 spatial streams. So we start to see 4 by 4 wave 2 AC access points. The most important one that they did wave 1 versus wave 2 is multi-user MIMO. Like I said, with wave 2 AC only, you can do a multi-user access to the access point, up to 4 access points at the same time. Basically, it's up to 4 spatial streams from 4 different devices. So if we go back to this chart, when we see, okay, if we have 4 iPhone 6s in one environment connecting to a 4 by 4 wave 2 AC access point, then all those 4 phones at the same time can talk to the access point, and they will see no delay in terms of contention. But if there are, 2 iPhone 6s, only 2 iPhone 6s will talk at the same time because each iPhone 6s has 2 streams to the access point. So that's a major difference between wave 1 and wave 2. But again, wave 2 doesn't come cheap. It comes at a price tag that is pretty steep at now. All right, so same thing from mobile, we start seeing from laptops. So MacBook Airs and MacBook Pros are the most recent ones. They have 3 by 3 antenna configurations as wireless AC. It's 80 megahertz channel bonding, so they haven't adopted the 160 megahertz channel bonding yet, and they go up to 1300 megabit per second because of the third antenna. If you're a Dell shop like we're here at SnapAV, this is actually the exact model of mine, or maybe a generation before. It's E726 or 7260. It's 2 by 2 AC. It's 80 megahertz up to 866 megabit per second. The higher end Dell, obviously, or HPs or what have you, you got the XPS, or they are the MacBook equivalent. So you get the 3 by 3, the higher end chipsets and antenna configuration. So with that being said, we are very excited to announce that we are a little bit delayed, but we're here. We're getting ready to launch our new line of AC access points. And starting end of May, you'll start to purchase and buy our new AC access points from SnapAV. So these are the 2 new models, the 500 series and the 700 series. And by end of May, this will be the entire lineup of the access points. The 100 and 300 series that you already know and love, and we appreciate your support. We love seeing our install base and our dealer base increase every month. So those will continue to be the N models. 500 and 700 will be ABGN and AC backward compatible. So they will be the AC models. Both models will have a gigabit LAN uplink that go to the network. By definition, both models will support dual band concurrent operation, 2.4 and 5 gigahertz. The 500 series is a 2 by 2. We'll call it an entry line to AC, so it's going to be a good AC option for your everyday job. So it supports up to 1200 megabit per second combined throughput between 2.4 and 5 gigahertz. The 700 will be a 3 by 3 AC, so that will go up to 1750 megabit per second combined throughput on both 2.4 and 5 gigahertz. Both models are wave 1. Like I said, both models support 2040 megahertz channel bonding to be more in line with what we see in the market today from end devices. And both models are high power. They are really not short on power. Even competitive products that say high power, they are basically half of this power. So on 2.4 gigahertz, we are supporting 28 dBm maximum power. On 5 gigahertz, 26 dBm. We couldn't get beyond 28 dBm because at higher modulation with QAM 256, once you get to that level of sampling, the signal gets choppy if you go beyond this range. Both models are standard PoE, so we still stand behind standards with IEEE. We do not do any passive PoE or proprietary PoE. You can plug in our access point with our PoE switches or any standard PoE switch, and we'll power on. Both models will support beamforming, chipset-based beamforming. All models will be overseas enabled out of the gate. You get all the exciting new features that we introduced from overseas day one on 500 and 700. And all models will support fast roaming day one. And obviously, all models come Wi-Fi certified by Wi-Fi Alliance, AVG, and AC. So this will be the exciting, very anticipated lineup from Araknis in terms of AC, the 500 and 700 series access points. You will see the pricing when we put the item pages on coming soon. We believe that the price will be very, very compelling for you guys, and we're super excited to introduce this product. It's been a long time in development. So we talked about fast roaming at the bottom, that all the devices are fast roaming. So this will be a segue to our next topic from a technology standpoint, which is fast roaming. Actually, fast roaming, when we launched the 100, 300 series access points, we received an overwhelming request for wireless controllers or hardware controllers. And we spent a lot of time talking to you guys either on the phone or at CEDIA, or we've had sessions here at SNAP and in the headquarters that we brought dealers in. We shared a lot of ideas. And basically, when we talk about the wireless controller, we found out that there are two things that we want to talk about. Or what dealers reference to wireless controllers. One of them is roaming. The other one is centralized management, or both. So when a dealer calls and says, "Hey, I want a wireless controller," or "I want you guys to do a wireless controller," it's either they want roaming, or they want centralized management for location, or they want both. But controllers or Wi-Fi as a system, it didn't get here, out of the gate back in '97 when IEEE introduced 802.11. It was there was an evolution in terms of the systems themselves. So this slide is actually taken from a company called Airhive, and they did, I think, a great job of summarizing the evolution. So if you look at the top, so the first generation or first system, when first access point announced in the late 90s, the access points themselves were autonomous. So they were standalone devices working on their own, connecting Wi-Fi devices to the back end. And there's a network management system software that controls or manages the entire network, and that's usually very expensive and sits on very high-end servers. And then, vendors looked at this and say, okay, Wi-Fi is really not a one-point solution that's being deployed in businesses or enterprises. We see that there's multiple access point environment because there's limitation to Wi-Fi. And we need to find a way to actually control those access points. But the processing power on those access points at that time was not that great. So let's create a box that's called a hardware controller or physical controller that is very rich on resources and processing power, and keep the access points as dumb as they can be. So they will be only directing traffic from wireless to wired, and all traffic will go through the hardware controller. And the hardware controller will do all the decision making, will do all the traffic forwarding, and life was good then. Then processing power started to increase on the access points. The Moore's law of with time the chipsets will get faster and cheaper. The access points start to get stronger resources, stronger processing power. And also, the controller functionality, they said, the OEM, networking OEM said, okay, we can, have the access points do some of the decision making, and we will do a lot of important decision making still in the controller-based environment. And that controller can be either, a hardware box, or it's really a software on hardware. So let's virtualize the software, and you can put it on a server. So some companies like Ubiquiti, they do a software controller, but you can host it on a PC or on a server, or you can put it in a little PC box that they can drop in every job. And that works fine. That's okay. But then other companies like Meraki, they said, okay, the access points themselves are getting very strong. And since we're already virtualizing that software, why not we do it in a cloud-based environment? So we get economies of scale, we get a very powerful architecture. Cloud-based computing is gaining a lot of traction at that time. So let's do a cloud-based controller. And they've done a phenomenal job, and they got acquired by Cisco. But now the technology evolved even further. So chipsets are even more powerful and a lot cheaper than they used to be. And companies say, all right, let's do the access points. Let them handle all the decision making. Let them handle all the traffic forwarding, and we will do only cloud-based management. And companies like Aerohive, like us, we believe in this approach. We believe that you should not penalize a job for a hardware box on every box. That's another point of failure that you can manage. And the access points by themselves are powerful enough to handle all traffic, all traffic forwarding, all decision making, and roaming capabilities. And we will give you the ability to manage those access points in a cloud-based environment. So there's no right or wrong in the evolution, other than number one, obviously. But some companies, competition today, they introduce a hardware box in every job that you have to install. That's a physical controller. They work. That's fine. Some companies like Ubiquiti, they do a hybrid controller. It's a virtualized environment. You can put it on a cloud server. You can put it on a physical server or PC, and that works. That's fine. Some companies like Meraki, they do fully cloud-based controller. So you need to have that cloud-based connection to work, and that's fine. And some companies like us or Airhive or other companies out there, they believe that access points should stand on their own as a closed system or as an integrated system, and you have to find a cloud-based management solution for them. So that's our approach, and that's why we introduced the latest firmware 1.1.06 and to introduce fast roaming. But fast roaming, when you're trying to address the fast roaming or the roaming capabilities, the underlying technology is two standards. The first one is 802.11k, the other one is 802.11r. So I'll speak to both standards. 802.11k, if you see, it's an IEEE standard. This is nothing proprietary that we developed or anybody else developed. This is IEEE. They amended the 802.11 standard with a lot of advancements based on the market research, and so we're trying to standardize this across the board. So in 2008, they introduced an amendment which is 802.11k, and this amendment basically is about radio resource management, and it basically enables access points to report and communicate other information of the environment to whomever is asking in order to facilitate management of mobile wireless LANs. So here's how the process works. Let's assume we have 3 access points in one environment, and we have a client connected to access point 1. So client is moving away from access point 1. The access point tells the client through 802.11k that, hey, you're moving away, or your signal is dropping from me. Get ready to move to another access point if there's another access point in the environment. So the client says, okay, thank you for letting me know that, but tell me what are other access points in my environment that I can connect to. So access point comes back and say, okay, this is a site report. This is all the access points that are, in the neighborhood, and these are their capabilities. And then the client determines that, okay, I'm going to pick access point number 2, not access point number 3, because it has the best signal strength for me. It has the same security settings. It has the same SSID. I'll jump on that channel that the access point 2 is on and connect to it. So that's the first part of fast roaming, 802.11k. The second part is 802.11r. It's also the same year, ironically, 2008. IEEE amended the standard and say, okay, we want a roaming standard. Multiple access point environments is becoming very prominent, and roaming is a problem that we need to address. So 802.11r allows for continuous connectivity across access point for wireless devices that are in motion, and also allows not only speedy roaming, but more importantly is to maintain a secure connection between the access point and the client. So here how the process works. So go back to our example of 3 access points. So client determines that he's going from access point 1 to access point number 2. So client was connected to access point 1. Initial connection, they established, they have the SSID, they have the security authentication, and they have some QoS policy. Life is happy. And then they start to move away from access point 1 using 802.11k. Access point 1 told them that, told the client that, hey, you're moving away. Here's the site report. You should connect to other access point. The client said, okay, I'm going to pick access point number 2. So while the client is still connected to access point number 1, the client will start the association process with access point number 2 because they still have to, handshake on the SSID name and the security and make sure that, they are authenticated with access point 2. So they keep working on access point 1, traffic going to access point 1. In the background, they're connected to access point number 2 and doing the authentication. So when the client moves to an area where the majority of the coverage is the stronger signals coming from access point number 2, client determines that, okay, I'm going to jump on access number 2. So the client reassociates, so disconnects with access point number 1, reassociates with access point number 2. But since it's been pre-authenticated, basically, the association process is much faster. On a normal process, it takes seconds. Now it takes milliseconds. So that's how the client will maintain connectivity with access point number 1 and quickly roam to access point number 2. So the combination of both 802.11r and 802.11k will enable fast roaming to be very effective and very seamless. But that does not come with no considerations. So you need, as an installer, to make sure that there are some design guidelines that on every job in multiple access point environments you need to follow. And first and foremost, you need to properly plan the location of access points. This is a very important step in order to guarantee a good performance of your Wi-Fi system. And we'll talk about that in our practical guide in a second. The second one is dual band solutions trump, no pun intended, single band solution. Dual band solution. So I read also another statistic from Wi-Fi Alliance that by 2019, 92% of end clients shipped worldwide will be dual band, 2.4 and 5 gigahertz. And that's very important because dual band, 2.4 gigahertz as a medium is really congested. This is a lost war. This is a lost battle. Do not try to cram stuff into 2.4 gigahertz unless it's super clean environment. If you're in a city or in a crowded neighborhood or a townhouse situation, 5 gigahertz is the way to go. So we would like you as a vendor to stop buying our 100 series access point and start buying our 300 series or 500 series or 700 series access point. That's highly recommended. Also, because it's dual band, utilize band steering. So some of those clients will have 2.4 only. Some clients will have 2.4 and 5. But use band steering to have the access point, force 5 gigahertz client to move to the 5 gigahertz bandwidth or band and have a great experience and reduce the congestion 2.4 gigahertz already. But when you have a situation when you have multiple access points that you want to enable roaming, we highly recommend using different channels for adjacent access points. I know some of the competition, they recommend using the same channel. That's their recommendation, that's fine. But we stand behind different channels because if you have 2 or 3 or 4 access points in one environment, they are all on one channel. There's something called co-channel interference. You can read about it in my blog. And basically now you're introducing a lot of co-channel interference. Basically, access points without any traffic, they are clogging some part of that channel because of overhead. So that's why you need to have a non-overlapping channels in adjacent access points and plan for that. Also, it's very important to see in the graph here, there is an overlap area between access point 1 and access point 2. in terms of coverage. So that overlap area is very important to plan. This is the fine-tuning. This is where you come in as an installer and add that value add. So it's not as simple as throwing access points in the job and just walk away. You need to make sure that the overlap area is there. It has a good signal. It's not too strong, so you don't want those access points to overlap too much. Then the client will be very confused about where they're going away from or where they're going away to, and you don't want it to be minimal, where the client will have basically no connectivity to any service until it dies and then picks up another access point. So we recommend in this overlap area the RSSI value or the received signal strength indicator value to be between minus 75 dBm and minus 85 dBm. This is a good signal. It's not a great signal. It's not a super weak signal. And this way you will assist the client to make the decision to move from access point 1 to access point 2. But also because we saw in R that this is a pre-authentication and re-authentication process, we recommend using the same SSID name on both radios, 2.4 and 5 gigahertz, across the entire environment that you want to roam in. You can create extra SSIDs for special requirements if you want. That's fine. But the main SSID or the main network that that the clients or the end users will connect to all the time, it needs to be the same across those access points. And also, not only the name, but the security settings. That's a very important step. The security settings across access points should be the same. We highly recommend WPA2PSK, which is the most secure and certified by Wi-Fi Alliance. But some of the legacy devices, very old devices, they do not support it. For those devices, we recommend to create a separate SSID for that access point if it's local only, and have it a less secure access SSID. But for your main SSID, make it very secure with WPA2PSK. Also, enable fast roaming on all access points that you want to roam. Fast roaming by default, even with the new firmware, is disabled because there's a catch here. The clients must support 802.11r and K in order for fast roaming to work properly. Because we saw when we explained the process, the client makes the decision to roam, not the access point forcing it. But there's a collaboration between the client and the access point in order to facilitate that transition and make it very easy and seamless. So we ask which clients support 802.11r and K. The good news is that most Apple devices in the market, they support it natively. So anything that is iPhone 4S and newer, iPad 2 and newer, Mac 2008 and newer, they support natively 802.11r and K, and this is the majority of the install base. Like I said, Samsung usually is ahead of Apple on the technology standardization realm, so you can assume that the Galaxies S7, S6, and X5, they support R and K. We've seen in our testing instances where iPad Gen 1 did not support it. Some of HP printers, they do not support it. The bad news is that if a client does not support 802.11r and K and fast roaming is enabled on that access point, then the client will not be able to connect to that SSID at all. And that's because R and K, they add some overhead bits on the communication, and the client that doesn't support it, they can't read it. So they assume that this SSID is faulty and they will not be able to connect to it. So that's why it's disabled by default. We do not want you to update your firmware in the field and receive a bunch of calls that says, hey, my HP printer is not connecting, or I have an iPhone 3GS and it's not connecting to my network anymore. So make sure that you enable fast roaming on all access points that you want to deploy in the field. And we were skeptical too. So we know standards work. We've seen a lot of test data from Wi-Fi Alliance, from IEEE, but we wanted to test ourselves. So we deployed a 2-access point environment. There will be a document to walk you through all the tests that we've done to validate the feature. But basically, this is one of the results that we found. So this is a chart on the y-axis is megabytes per second. We're doing a FaceTime session. And on the x-axis is seconds. So you can see on the left, there was a FaceTime session between a mobile device or an iPhone that is stationary, so standing and connected to one access point, and there's another iPhone roaming from one access point to another. And you can see, the choppiness in the megabytes or the transmit is depending on the environment and what kind of content is being transmitted. But you can see that the number of bytes or the traffic drops here for about 2 or 3 seconds, and then it picks up in this area where it was connected. This is a overlap area when you have, it was connected to access point number 1, then access point number 2, then it dropped a little bit, and then connected fully to access point number 2, and they're smooth. So that's on the packet side. What we saw in real life is that during this transition period, we saw some pixelation in the video. The audio stayed connected flawlessly. The session did not drop. There was traffic going on, and once we picked back up, picture cleared. Audio can continue to be as good as it used to be, and the session did not drop. So that's a very important test that we found, that as an end user, this is a use case when they will roam, talking to their peers at work, doing FaceTime sessions or Skype sessions. So that concludes the first part of our session, which is the technology part. We explained wireless AC, the evolution of wireless controllers, and what does fast roaming mean, and how we tested the fast roaming. And now we will do, we'll go to the more practical thing of part of the session, is that what are the, we receive a lot of calls and a lot of emails and a lot of conversations with you guys, and basically you're asking us, hey, what would you do in order to ensure that a multiple access point environment is properly configured, is going to work, and I will stand behind it? And that's a great question, because you as an installer, you are in touch with the end users, and you are in touch with their pain points. And their pain points usually is based on consumer-grade products. So an end user in the life, they went to Best Buy, they bought an all-in-one Netgear router access point thingy. They put it in a basement or in an attic. This is really not an optimal location for Wi-Fi, and they can't get coverage. If they get coverage, they can't get the speed. They have to reboot the thing every day or two. They are very frustrated with their Wi-Fi experience, and that's because it's a consumer-grade product. It's not a professional-grade product. A consumer-grade product does not meet the the increasing demand of the connected devices today. Basically, you can see here on the right chart, because we're members of Wi-Fi Alliance, we get access to their research. The average U.S. household has 5.7 connected devices today, and that's a quadruple or a double from what it used to be in 2008. And then what we say here is that 1 in 3 adults in the U.S., they own a tablet, and those tablets are Wi-Fi. There is no tablet that I know of that has an Ethernet port. Maybe you have a dongle that you can use it, but the majority of it is Wi-Fi based. And 60% of consumers say that they will use Wi-Fi for multimedia application, and 60% use Wi-Fi to stream content. And this is even the most important statistic, is that 69% of millennials, they said that a Wi-Fi outage is more disruptive than a TV outage, because that's how they consume content today. Everything is streaming, everything is on demand. So more millennials will go into the workforce, more millennials will buy houses and get into a home ownership, then that statistic will become very, very, very important for you as an installer. So end consumers do not trust your service providers. They do not trust Time Warner or AT&T or whatever you have in your area. They've felt the pain while they were in college or after college in their apartments. They know the service is bad. They know the product doesn't work. They trust you as an installer to be their consultant in terms of their technology. And this is a huge opportunity for you from a business perspective to make Wi-Fi your brand. To say, okay, I will provide you with the best Wi-Fi experience, and I can stand behind it. And this is, once you deliver on it, you get referrals and you get more business. That's very important. So that's the business side of things. We go into steps. So how can you deliver a successful multi-access point environment? We have a 10-step process that we documented. I'll share it with you. I'll share with you what the document's live today. That we recommend every installer to do on almost every job. And step number one is invest in tools. We talked about tools. I've blogged about tools. It's very, very important to make sure that your techs are properly educated, properly trained, and properly equipped with professional-grade tools that will enable them to know what's going on and help them in their install. And we talked about, multiple providers, and MetaGeek actually is one of the best in the industry in terms of doing a spectrum analyzers. Very cost-effective spectrum analyzer. If you want to talk about, labs and telecoms, my background is telecom engineering, those spectrum analyzers cost hundreds of thousands of dollars. What MetaGeek did is, make a solution that is very, very cost-effective and very, very powerful. And they partnered with Ekahau to also distribute site survey using their one product, and they provide a solution. So MetaGeek is a really great company that provides excellent tools for Wi-Fi professionals. And for you, as our audience in this session, we are very excited to announce the second big announcement that we signed an agreement, partnership with MetaGeek. And within a month or so, you'll start to buy MetaGeek products from SnapAV store at a discount for you as installers. And actually, June, we will have a co-hosted webinars between Araknis and MetaGeek to walk you through the solution, their product line, and do live demos and why you should care about MetaGeek products. So we're super excited to bring you guys options to invest in your business and invest in your techs and your success. So that's step number one, invest in tools. Make sure that you are properly equipped to deliver on this Wi-Fi experience. Step number two, and we talk about it a lot, documentation, super important, especially for after install support. There is really no template. You create your own template. Think about any Wi-Fi experience or any job that you want to walk the customer through, and think about all the different aspects that you want to capture for that job. Before the job install, during the job install, and after the job install. Spend the Sunday night invest in yourself while you're watching the playoffs or watching a game. Think about those different situations and create your own template that you will distribute on every job. Use different tools are available now. I'm a big fan of Evernote. It's a cloud-based note-taking system, but Microsoft Office 365, they have OneNote. It's a great product. Or you can create a simple Excel spreadsheet that you can capture this information and create a different file for different customers. Whatever works for you, you make your own tool for you. But documentation is super important, because 6 months from now, you install the job and somebody calls you from that job, say, hey, I forgot my password or whatever it is. It's very efficient and very effective that you can reach out to your notes, quickly solve the problem. You're not losing time. Your customer is very happy, and you're still delivering on your promise of Wi-Fi or is your brand. So let's say we have a new customer that you want. They contacted you for their Wi-Fi experience and that you want to interview them. So spend the time with them, do an interview, ask them about their experiences in the past, what they struggled with, what kind of equipment they used before, what kind of applications they use over Wi-Fi, what kind of devices they use over Wi-Fi. Capture all that information. If it's a new construction, make sure that they share with you the floor plan so you can look at the floor plan and plan on where you want to put your access point based on the space that you have. But also ask about the materials of those different aspects of the floor plan. What kind of materials you have on the wall? Is there a fireplace? Where the kitchen is? These are very important questions that you know as you plan your location of the access point. If it's a retro job, ask permission to do a site survey. Do a quick site survey using a spectrum analyzer. It's very important to know pick 3 or 4 different spots in the job. Look for trouble spots and see what kind of spectrum you're looking at. So this is an example from Channelizer Pro from MetaGeek. It's on 5 gigahertz. So you can see like this channel is very congested or there's a lot of traffic here and you got this empty highway here on the left, so in case that the access point picks up that channel, you know this is, it has some traffic into it, and you have way better options elsewhere, so you can move it to move your traffic to the empty lanes. So very important to just set the expectations right and understand your customers, and it's a time to bond with the customer and make sure that you deliver using your sales period and the pre-sales period. So hopefully they get excited, they get bought in, and and you get that deal. Then you go to the job site and start planning the location of the access point. Things to make sure that you avoid or be aware of is concrete and brick walls. They distort Wi-Fi signals significantly. Metal studs, they add a lot of interference. If you have the situation like in the picture here in the basement, this is a Faraday cage, we call it, so it creates a lot of noise, a lot of interference in Wi-Fi. This is really not a great spot for Wi-Fi to distribute across the house. Maybe you have a small access point here with low power that covers this basement, and plan your access points elsewhere. The kitchen area is very troublesome in terms of Wi-Fi. Everything that has a giant motor, it naturally emits 2.4 gigahertz interference. So avoid that kitchen area and make sure that you plan around it and not use an access point in the kitchen area to cover the entire house, because your signal is distorted out of the gate. What we recommend is you put the access point as central, as high as possible, but also be aware of the coverage and the site survey that you run into. So those different environments, they will affect your coverage area. Other devices that they use 2.4 gigahertz spectrum, that they are non-Wi-Fi, cordless phones, they still have those things, nanny cams, microwave ovens, wireless audio systems, they all emit non-Wi-Fi 2.4 gigahertz traffic. The problem is that, if you use the highway analogy, Wi-Fi traffic is cars. Non-Wi-Fi interference from those sources is like introducing deers in the highway. There's no way you can go around it. It slows everything down. You can't control it. It's really, really disruptive. So that's when it comes to, you picked up your locations. Also, if you have a question mark around a couple of locations, it doesn't hurt to run wire to that location and keep it in your back pocket, keep it hidden. In case you find out after install that you need to introduce another access point, then it's ready for you. You don't have to retro a wire pull, especially in new construction. So keep a spot or two in your back pocket, ready for another access point to pop in case you need it. But hopefully, you've done your sales job greatly, and the customer is happy and they bought in. And so it's game time. You want to install the access points. You get our Araknis access points. We provide the most versatile solution in terms of installation for the installers. Our access points can be ceiling mount, which is what we recommend, but they can be wall mounted or they can put on the shelf. We provide you a lot of installation flexibility in terms of the back plate that can support multiple junction boxes. If you have a drop ceiling situation, we have a back plane to sandwich the drop ceiling tile so the access point doesn't sag or hang. The design of the access point itself, we thought about the end consumers first, then actually the installer first and consumer second. And we try to make it as elegant, as discreet, as silent as possible. So if you want to keep them exposed on a ceiling, you feel very happy and very confident that you can keep them exposed and they will not disrupt the end consumer's life. And then, utilize oversee. This is where cloud-based management becomes very, very effective. So you want oversee to be your initial portal for initial setup. So this is, you find the quick start guide. The access points are DHCP out of the gate. And they need a live network in order to get an IP address. They can default to a default IP address, but you don't want that. So these are the different situations that you can power the access point. We recommend the PoE switch, obviously, if you have a multiple access point environment. But you can power the access point via PoE switch or a PoE injector or a DC power supply that can be sold separately. then you connect, so make sure that the network is live before then, so the router at least is live and is distributing DHCP IP, so the access point gets an IP address. If the internet is live, the access point automatically calls oversee and it's ready to be claimed on oversee. And here I'll give you an example of, this is a demo site that we have in oversea. So this is a site, we call it Aaron Jones. He has a location called home, but he also has, other locations called SnapAV office. So this is a demo rack that we have, and you can see you have multiple devices that you can claim on oversea, and we support a plethora of devices that are SnapAV devices and some third-party devices. So this is an example of a site that we have a 100 series access point and a 300 series access point. So a 300 series access point is here. I can click on it on the cloud portal, and I can show you some of those new features that we've introduced in the latest release. So you can see here that we have the access point is online, the 2.4 gigahertz radio is online, the 5 gigahertz radio is online. This is my CPU utilization and my memory utilization. So system resources are okay, they're good to go. And these are two views that you can see are new. So this one is a traffic histogram, and that's a very important view. So I can click on the monthly view here. And you can see this is the traffic that's been running through the access point over the past month by day. And it's showing both 2.4 and 5 gigahertz radio. If I want to see 2.4 gigahertz traffic only, I can see it. If I want to see 5 gigahertz traffic, I can see it. But that's an important feature because sometimes a end consumer calls you on a Monday morning telling you that, hey, Saturday my network was down. So you can go log back in and see, okay, let's see the week view here and see, okay, on a Sunday or a Saturday there was really no traffic going through the access point, so there's something wrong with the access point. But on a Tuesday, there's traffic going through the access point, but if the client says that, there's no internet, then maybe I should look somewhere else. The access points are okay, but maybe the router is not okay, or maybe the ISP is not good. Okay. And also the client list here, the client table is similar to what you find in the local UI. It tells you the connected clients and their signal strength, and you can kick them out of the network if you want to. But for initial setup, this is a very important feature here. We go to the Configure tab. Now you can do on each access point, I can add a new network. Click on Add New Network, and this is where I can configure my initial SSID. It's broadcasted, so I can, say I can make an SSID that is not broadcasted, so it's going to be hidden SSID. I give it a name, say it's test. What radio is it, 2.4 or 5 gigahertz or both? We highly recommend both in a situation with 300 access point. What security? Is it open or WPA PSK, 2 PSK or WPA PSK mix or whatever? We recommend WPA 2 PSK. Give it a password, whatever it is, and save. And this way now you configured your SSID. Also, because of the 300 series access point, band steering is enabled by default, but you can disable and enable band steering globally here per access point. But one of the cool features is you can enable guest network per access point through oversea. And also, let's say 6 months from now, somebody calls you for this site. So Aaron Jones calls you and say, hey, what was my Wi-Fi password? It's like, okay, what's SSID? And they say, it's okay, the oversea demo. So you can click on it. Oh, this is an open one. The test network. So you can click on it, and you can scroll down. You can see the password for the SSID. Quick, efficient. You solve their problem in double clicks. It can be through the mobile apps, or it can be through the desktop. It's a very good customer experience. And obviously, you can change the IP settings because, like I said, the access point is DHCP out of the box. So you can see its IP address here. You can access the local UI if you want through the IP address or not. But we recommend using all network devices as static IP. So you can click on static, give it a different IP address and different gateway, and hit save, and we'll be good to go. Other than that, the cool feature is that you can reboot the whole access point if you want to, or you can click on this More Web Connect. You can launch the local UI remotely through oversea. So click on Remote. It will open up the local UI, and I'll show you in a second why this is important. So that's step number 6. So you got your network is up, you install your access points in the locations that you picked. They grab a DHCP IP address, they call oversee, you claim them, you put them on that job site, you do your initial setup in terms of the SSID and the IP settings, and now it's time to get the magic going. So now it's time to get those tools that you invested in into play and do a site survey. So this is an example when we have a floor plan that we installed 2 access points and we did a walkthrough. So each of those white dots is a measurement point that we stopped, collected, looked around in the environment and collected that information and went to the other spot and so on and so forth. This can be a little bit tedious, I'm not going to lie, but it will make your life a lot easier during and post-install. So you collect all those measurement points, you get this heat map. Blue is very strong signal, green is an okay signal or a good signal, and then it goes down all the way to yellow and red when you have a really bad signal. Why is this important? When you do the site survey and you do the walkthrough, you will discover dead spots. If you have a dead spot that you need to address, if you have a trouble spot that you need to address, when you have spots with red or yellow coverage that you need to address. But also, this will tell you for your roaming experience. So for your roaming experience, on the left side here, this is an okay, so it's covered. We have really strong signal. But we got 2 access point situation here. And in the middle where we want to roam, you got really strong signals. Some of those signals are coming from access point 1, some of them are coming from access point 2. So what you want to do is you want to dial back the power on one or both access points so that can be on, similar to something on the right side here. You want some good signal strength, not a super strong signal strength in the in-between area. So you can assist the Wi-Fi devices to roam between the 2 access points. Also with your site survey, you can see each access point, what channel they're propagating on. So you can use your spectrum analyzer in order to get to the optimal situation. So I'll show you quickly on the local UI. So we launched a local UI through Oversee. And this is local UI of a 500 series access point. This is actually in my apartment. I'm running on different firmware versions because I'm beta test. But basically, you go under settings, under wireless. You can see on 2.4 gigahertz and 5 gigahertz, you have the operating channel. So this is where you have your lanes on the highway on 2.4. It's auto by default. So you can pick, you can force on which channel you want to be on. And on 5 gigahertz, you have more options, obviously, you can pick from. And this is when you have the channel bonding or channel bandwidth. So it's 20 megahertz by default on 2.4 because realistically speaking, this is the maximum you can get on 2.4. Because this is a 500 series access point, it's 80 megahertz. And when you pick 80 megahertz, actually auto 80, 40, 20, so it's backwards compatible. So this is where you select your channel. So if your spectrum analyzer says that, hey, you are on channel, you are on channel 1, and you need to be on channel 8, then you can force it on 8, scroll down, hit save, hit apply, and you'll be good to go. Also here when you enable fast roaming, so you can see under global settings, we saw that band steering can be enabled, disabled through Oversee. You can enable it, disable it here per access point on the local UI, but also fast roaming, this is the second option that you can enable and disable. So to enable fast roaming, really, is click on toggle. So this will be off by default. Just toggle it on, hit save and apply, and you'll be good to go. But the Wi-Fi overlap coverage areas, this is where you want to get your magic going. So under advanced, under wireless settings, this is where we see for both radios, you have the transmit power. So by default, it's on full speed or full power. You can dial that back to 80%, 50%, or 30% as presets we made for you. Or if you're not that savvy, it's like I'm on a custom dBm range, and it's okay, I'll put a 24 dBm or 25 dBm here. We can do 35, 25. Hit save and apply, and you'll be good to go. But also for the guys that don't believe in dBm. They are more of a watts person. You can click on the toggle here in milliwatts, and you can see the maximum is 800 milliwatts, and you can have the presets in milliwatts as well. So that's it in terms of where to go and dial back and fine-tune your settings on the access points. It's really simple. It's basically just utilizing and investing the time and the tools to make the right thing. So after you site surveyed, you dialed back your power, and you went back and updated your site survey, made sure that everything is good to go. Spend some time and do some tests. So those tests can be speed tests, the normal speed tests that you do. You can do a iPerf test between devices, Wi-Fi to Wi-Fi or Wi-Fi to LAN. But also, very importantly, since you interviewed your customer, use the applications that they told you they will use, and make sure that it works the way it's supposed to work. So if they're streaming Netflix from Amazon Fire TV on their Kindle, whatever it is, so use that and stream it and roam around and make sure that's working. And have fun when you do it, like the guys here doing a Skype call and having fun with it. Step 9 is finalize your notes. So make sure that the template that you created for yourself is utilized, that you use it properly. Finalize your notes. If you want to use a digital note or old school note taking, that's fine. Whatever floats your boat. And the final step is more of an optional step, but I think it's great, is use a report. Share a report with the customer that says, okay, this is what went into your great Wi-Fi experience. This is the steps, or these are the things that I've done, and this is what I've found. And given the reason behind it, that gains confidence, that sells your brand. And this is one of the things that we like Metageek, because Channelizer Pro, they have a report building tool that you can basically from each site create a report as PDF. You can save it for your own records, but also you can share it with the customer. You can put your logo on the front page, and you'll be good to go. So that's it. These are the 10 steps that we recommend to successfully install multi-access points environments. To recap, first step, invest and learn your tools. Invest in your personnel and your techs. Second step, spend some time thinking about those documentations and how you want to document each job. And then when you have a new job, spend some time with the customer, understand their needs, and site survey their location. Plan the location of the access points to be as central as high as possible with the open environment. Install our versatile access points. Utilize OverC for cloud-based initial setup. And don't forget that the dual band situation is better than single band situation. Non-overlapping channels for adjacent access points. Avoid congestive channels. Step 7 is super important, to heat map and fine-tune your setup for your roaming experience. 8 is equally important. Test and validate your setup using the traditional networking tools, but also use the applications that the customer told you that they will use. Step 9, also equally important, back up your files, back up your configuration file, back up your everything that you've done for that site, store it in a location that is organized properly, finalize your notes, and then step 9, step 10, share your pride and then your product with your customer. All of those steps before we close out, I want to point out that they are available to you on our website. So if you can go to snapav.com, on the item page, either the 300 series or the 100 series or the upcoming 500, 700 series, go on the support tab. There is, under manuals and guides, a document called Successful Wi-Fi Installation Guide. And you can click on it. It's a PDF. You can download. You can read on your own. Basically, it walks you through all steps that we talked about and have some more visual that you can look into. And with that being said, we get to our Q&A session. Heidi.
All right, thanks, Aham. That was super helpful. And we had a ton of questions come in during the presentation, but just as a reminder, you can send those in using the question and answer feature on the GoToWebinar control panel. All right, let's get to the first one. Have Araknis WAPs been tested with URC remotes? And if so, do you have any best practices or best settings to use there?
We have, I'm sorry, can you mute your?
Yes.
Hi. sorry, we have some echo situation here. So we have URC remotes obviously in our lab. We've tested with URC remotes, and actually these are URC remotes were one of the test cases we've done through development that we found some bugs that we've fixed during development before we rolled out any product into the market. No special settings that I know of, but if you have any situations that you went through in your life and you say that, for other vendors that you found a problem with URC, I can tell you that we tested with URC and they work to our knowledge, and also we have a couple of dealers as beta sites that use URC, and they work properly and with no problems to our knowledge. But use our couple of access points. If you find any problem, feel free to reach out to us and we'll be more than happy to work out with you.
Okay, next question. You talked a little bit about band steering, but can you go into a little more detail and share pros and cons?
Absolutely. So band steering is a technology that basically, if you have a 2.4 and a 5 gigahertz client, that means maybe your iPhone, and when they want to connect to a Wi-Fi network, they send a request on both 2.4 and 5 gigahertz to the access point. And without band steering, the access point will see, okay, what is the strongest signal that I'm getting to that client, and they will send a response to that client for that radio. So if the strongest signal is 2.4, then the access point will tell the client to go to 2.4. But that's really not optimal because 2.4 is very congested. With band steering enabled, in this version of this generation of band steering that we have, the access point will always reply to 5 gigahertz. So it's always forcing those clients that support 5 gigahertz to go to 5 gigahertz. Because even the signal is not that strong on 5 gigahertz, the quality of the signal is way better on 5 gigahertz. So it's a better experience for the 5 gigahertz client rather than being on 2.4. So that's what band steering is doing. And you can look at our manual. It explains it more in detail. And I can tell you that we are working on an iteration of band steering that will be, we'll have 2 or 3 modes that we will explain in the future when we roll out some updates.
Okay, sounds great. For the new AC WAPs, this is a quick question. Do you have comparison charts for PackEdge and other competitors?
In terms of feature spec, yes. Once we roll out the item pages on coming soon, and that will be, I think, within next 2 weeks tops, you will see a competition tab. So you can look at our spec versus the competition spec, PackEdge, Luxel, Ubiquiti, the usual suspects. And also, we are working with Spirent as a third-party lab that we will do benchmarking in terms of performance. At least at one distance, so we can see what the performance difference. I can tell you from a real-world perspective, the performance is equally the same in terms of all 4 brands. They all deliver on their promises. I think Ubiquiti, the new AC line, is very low powered. Even the long-range one is very low powered compared to the PackEdge, Luxel, and us. So that creates a lot of headache in terms of how you want to plan your access points. You probably need more access points in that job rather than fewer access points. But in terms of speed at a distance, I think you can see that everyone is within the ballpark.
Okay, one of our most popular questions today is, any plans for an outdoor unit?
Oh, great question. Yes, we are in development of 2 outdoor models. There will be a 100 series outdoor, so that's a single band N outdoor rated one for very budget jobs, very cheap jobs. We hope that you don't buy the 100 series outdoor, but we understand that there's a market need for a really budget solution. But also we're doing a 500 series outdoor, which is a 2x2 AC, 1200 megabits per second. We want those outdoor access points to be IP rated, hopefully IP66. I can tell you that we've done the industrial design, we finished that, so hopefully by the end of the year we will have the 2 models available for sale.
Sounds exciting. Okay, next question. How far can you run PoE from a PoE switch or injector to a WAP, and what's the max recommended distance?
Well, that's a great question. Each run for PoE is by definition 100 meters or 300 feet. So we tested our PoE switches, our PoE injectors to run at a maximum distance of 100 meters. So you can plan for that. There are products in the market, accessories, they are PoE extenders. So in case that you have a run that is beyond 100 meters or 300 feet, then you can put a PoE extender in between and then connect to. Don't plan on using multiple of those. We don't recommend more than 2 in the way because the signal will degrade with each hop. But highly recommend 100-meter one single run if you have to do 2 extenders.
Okay, here's an interesting question. The new access points are cloud controlled. If the cloud is lost, what happens to the control of roaming?
Yes, that's a great question. So that's when we go back to the evolution of controllers. If I can jump to the slide real quick. So basically, this is where what we introduce is number 5. If the connection between the access point and the cloud is broken, the access points are operating on their own in terms of roaming because all that decision making is happening between the access points and the client, and the cloud is not interfering with that decision making. So in case there's an outage in internet, your roaming inside the location will work flawlessly, as good as it is, but you will not be able to manage those access points. So you'll not be able to create SSIDs or look at the histograms or reboot the access points if you want to, whatever it is, right? So cloud management is different than roaming. That's our approach, and that's why we feel this is a powerful solution. But great question.
And a quick follow-up to that one, if the cloud is lost, does the history during that loss get sent to Oversee when the link is restored?
In terms of histograms, I want to check with Oversee team, but I want to say yes. There's a buffer, a small buffer that we have in terms of the queue of the messages. Basically, every second, there's a status update between the access point or any Oversee-enabled device and Oversee, and that status update includes the counters for those traffic on both radios and the LAN interface. So I want to say there is some queuing and some buffering with outage. I don't know if it's going to capture for a long outage or not. I'll have to check with Oversee team. Good question, though.
Okay, so in environments where there's a lot of WAPs, like in a condo building or a townhouse area, do you recommend leaving the operating channel on auto in those types of environments?
Oh, fantastic question. Auto by default, so auto what means is when the access point boots up, it scans the environment and picks the best channel, and it stays on that channel for as long as the access point is operating. So in case there's a neighbor walked in, they moved in recently, and now they have their own access point on the same channel, the access point will not automatically adjust itself. And that's why actually with the latest firmware update, we added for this specific environment under advanced, there's a spectrum analyzer tab. I lost my connection to my access point, but I'll get it back in, right? So you can log in that situation to the local UI of that access point, go under advanced, go spectrum analyzer. And it's really not as powerful as the one as Metagee, because it's meant for this situation when somebody calls in and says, hey, 3 months after the fact, my Wi-Fi seems to be sluggish. Somebody moved in and seems to be sluggish ever since. You can see 5 gigahertz, and then start the analysis, and we'll start, giving you some sort of spectrum analysis in the environment. In my apartment building, there's virtually no access points on 5 gigahertz. But you can see it and say, okay, Mr. Customer, it seems like your neighbor just moved in and they're operating on your channel, so you can move him to a different channel. or maybe you think that it's a complicated situation that you have to roll a truck and charge them for your time, but use your MetaGeek Channelizer Pro, and that will give you a complete view and a more accurate view on the spectrum. But fantastic question.
Okay, we're almost out of time, but I'll take one last question. Is there any way for the customer to be able to control some of the settings, for example, scheduling Wi-Fi times to block their children, etc.?
Oh, great. Oh, yes. So today there's not, but I can say be on the lookout for more updates on that front. We are working on a very exciting initiative, and we'll address your situation, and it's going to be very, very exciting.
All right, well, that's all the time we have for today. And as a reminder, watch for our follow-up email with the recording of today's presentation, along with a survey and a coupon code for $50 off your next Araknis access point purchase. That should go out by the end of the week. And also, as you're exiting, please take a minute to fill out our 3-question survey just to let us know your thoughts on today's presentation. And thank you all for taking the time to join us. Have a great day, and we hope to see you next time.